The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI Web Sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Okay, good afternoon. All right, how's everybody doing? Okay, excited about this session today on innovative structural slab practices, specifically focusing on voided slabs. My name is Mike Mota. I'm going to moderate the session and I'm going to kick off the presentation. And I'd like to thank Committee 421 for sponsoring this event, a joint committee with ASCE. I am with CRSI, the Concrete Reinforcing Steel Institute, the Atlantic Region Manager up in the Northeast. And we have an exciting agenda for you today. I'm going to start by providing an historical overview of voided slabs. This may come across as something that's new, but what you'll see during the presentation, we're talking about an innovation on a concept, a well-established, time-tested concept. And that's really what we're trying to get across. We're just making it a little bit better. We're going to talk about the CRSI design guide for voided slabs that's currently being developed. And then we'll talk about case studies. And this is the exciting part about this. There are several projects that have been built and are in the construction in the U.S. The Miami Art Museum, the University of Wisconsin-Laban Arena, the Harvey Mudd College, and the other one that's not here is the Watertown Medical Center in Los Angeles that we're going to talk about as well. So we'll go through the presentation, and then at the end of each session we'll ask questions. You'll welcome you to ask questions, and we'll just play it like that. Okay, so let me start by providing an historical overview of voided slabs. I think you'll be surprised to see that some of the stuff that I was able to dig out of old literature is really, really interesting. And I'd like to start by showing some of the very early tests that were done at Purdue University. This is October 1907, looking at the hollow tile here. But again, the concept that you'll hear throughout the day is how can we reduce the dead load of the slab so we can spend further, be more efficient. That's really the name of the game. I thought I'd share this with you as far as material properties. Look at tensioning steel, 16 KSI, concrete, compressive strength, 750 PSI, shear in concrete, 75 PSI. Although they were very close to 2 square root F prime C, which was very interesting, even back in the day. And as a matter of fact, they had students, they were loading the slab with pig iron, as you'll see. I know it's hard to see down here. But they kept loading the slab. The slab was designed for 100 pounds per square foot, and they just kept loading the slab, and eventually they reached, I don't know, close to 500 or 600 pounds per square foot, and the slab wouldn't fail. And eventually they had to stop the test because the slab bottomed out. They had no more clearance below the slab to keep testing it. So, and here you go. The slab was designed for 100 pounds per square foot. They actually reached 710 pounds per square foot at the end of the test with 3-inch deflection. So, as you can see, very efficient. And here is the Purdue University team of October 1907. So, from a historical perspective, I think this is very, very interesting. Other systems that I came across, and if you look through the United States Patent Office, you'll see early in the 20th century, a lot of patents were sought out on this voided slab concept. Here you're looking at a particular system on tile, using tile. This one using cores in reinforced concrete floors. And I'll point your attention to this particular void here. I know you can't read this in the back, but this void was being made out of tar paper core. So anything to reduce some of the dead load in the slab was the name of the game. And so very, very interesting. And the innovation was already taking place. And this was 1914, as you see here. Other systems, again, showing voids here with metal forms. Again, the same concept, 1916. Something more in a two-way slab that perhaps we're more used to nowadays, but this was kind of the beginning with the two-way slab concept with voided slabs here, looking at the tiles again, reducing the dead load, and with the two-way load distribution. And this was, I dug this out of the Structure magazine. This was system 1915, Schuster system 1915. In the 40s, there was a large development in the Chicago area, a housing development, several hundreds of low-rise buildings. And one of the challenges that they had was, again, try to reduce that load and primarily provide a flat soffit, as you'll see here. And so the architect looked at different systems, and they decided to go with a kind of a voided slab concept, again, with the clay tile here, with concrete. And so they were able to achieve the architectural function that they were looking for, as well as reducing the dead load. And I can tell you that in many parts of the country, this is still a very viable system where tile is used to reduce the dead load and create kind of a voided slab concept. And so this was 124 buildings, a lot of, quite a large project. I thought I'd share this with you because nowadays we get involved with computer analysis and finite element, but you know, this is where we came from, if you will. There's a simple analysis, moment coefficients that we shouldn't lose sight of how these things were being done back before computers were available. So I thought this was interesting. More recently, in 1983, there was a project in Los Angeles, a very large project, where the architect was looking for different ways to minimize weight, to make the structure more efficient. And I'll show you in a little bit a chart that looked at the different systems. But the caption, and this was 1983, the caption says, voided flat plate slabs reduce cost and speed up construction. And this was a low-rise project in Los Angeles. You can find it in CI 1983. 688,000 square feet, 40 feet unobstructed spans, which the architect was looking for, long spans. Heavy live loads, 125 pounds per square foot. And the solution in this case was a one-way voided slab, as you can see here, with these voids creating one-way distribution of the load. So a different way from what we've seen up to now of creating a voided slab. Now, so the different systems that were looked at, again, this is hard to read, but they looked at structural steel, they looked at the precast plank, and you can see down at the bottom, so here is the cost in dollars per square foot on the vertical axis. The horizontal is the bay size, and you can see that it starts at the 25 by 25 bay size on the left, and it goes all the way up to a 60 by 60 bay size on the right. And you can see that the voided flat plate system shown here was the most efficient at about very close to a 50 by 50 base size. So, and that's the system that they ended up with. In this case, a one-way voided slab system. One of the challenges that comes with voided slabs, and you'll see different solutions in a little bit, is when you place the concrete. Obviously, you're displacing air here, so there's some buoyancy effect that takes place, and you need to be able to hold the voids down. So one technique that was used in this particular project was to anchor the voids down to the bottom of the formwork with clips that you'll see here. Okay, so this way, when the concrete was being placed, the voids were not displaced. There's not enough mass in the reinforcement mat above to hold the voids in place, so they had to anchor the system down. There's different ways of doing this, and you'll see that in a little bit, different strategies of anchoring the voids, but this is certainly one way that has been used. This is a longitudinal cross-section of looking at the anchoring places. So in this particular case, at about 4 feet on center, they had these snap tie hold downs to make sure that the void stayed in place. Other systems with the same concept, the flat terracotta arch, slag block. Again, the idea is to remove some concrete where it's not needed. The concrete in the middle third of the slab, if you will, is not really doing any work to carry the load. So if it's not needed, let's remove it and make reduce the dead load and make the system more efficient and be able to, again, have longer spans. More modern systems with a wide module joist. Some people call it a pant system or a skip joist system. Here we're looking at spans that reach 40 to 45 feet. The beam here, in order to be economical, needs to be at the same depth as the joist system. So often this is a post-tension beam. But again, you can have a very long span to depth ratio here, if you will, using the voided slab concept. And so different ways that this concept, as you can see, has evolved over the years. Waffle slabs are yet another application of a voided slab concept. Hollow core plank. Again, one-way load distribution here with the voids. A foam voided system, and we're going to really do the best we can at this presentation to stay away from proprietary systems, only because we want this to, not to be viewed as we're talking about a particular system. As you can see, there's many solutions to achieve what we're trying to do, but this particular system uses foam voids to create the same effect with a combination of a precast plank with a cast-in-place topping. So you have a composite action here between the precast, which you can see it's rough. So essentially there's a cold joint here, but it's a rough surface. And there is some truss reinforcement. It's hard to see, but you can see it down here, that acts as a composite action with the cast-in-place topping. So you come in, you put in the cast-in-place, the voids obviously stay in place. And the other advantage of this system is that these precast panels are stay-in-place forms. So that minimizes the need for form work and certainly speeds up, especially when it comes to having to reshore the slab, because this is a stay-in-place form. Okay, so my goal with the presentation was really to get things started, establish the fact that there's nothing, that this is a time-tested concept, and what you're going to see with the next speakers, Dr. Attila Braze is going to talk about the engineering principles with voided slabs and at least give you some indication of where we're going with the design guide, and then we'll have two other speakers that talk about projects. So any questions for now before I turn it over to Attila for the next presentation? Okay.